And now let's talk about electrolysis of an active metal. So electrolysis of aqueous solution of salt which contain an active metal. In this case, we took salt of a passive metal, copper, yeah, that was on the right with hydrogen. Now we will talk about active metals. Let's check which ones we have here. Here we take sodium chloride. Okay. So this is the reaction that you can see on the slide. We will do it next lesson here together. Active metal, sodium chloride. Look, it's in the yellow box. Look, sodium. Yellow ones, so they are very active metals. Yeah? Let's write it. Sodium chloride. And we add water, H2O plus H2O. So it's our aqueous solution. We will keep it and we will try the products here. We said it's our aqueous solution. Aqueous solution of sodium chloride. Sodium chloride is the salt that we add to our food and we eat. Now pay attention. In the first case, what happened? We are here. It should be like this. If we use melt, it was like this. When we use melt, we said that all the ion that present here will appear. Yes, it was in this form. In the case of solutions, it's different. It's opposite. If we have an active metal, instead of an active metal, we will get a hydrogen. Okay, hydrogen. And now let's figure out why. Let's try to understand what happens here. Let's say cathode and anode. So this is what happens with cathode. Since sodium is a very active metal, it reacts and interacts with water, it's very active. And we get the electrolysis of water. Instead of getting electrolysis of sodium, water participates in this process. So next time when we do this experiment here, we will use water, sodium chloride. Instead of getting sodium, you will be able to say electrolysis of water. And what happens with water? Look what happens, a very interesting thing. Water, the molecule will come to cathode. So cathode is negative, yes. Anode is positive. Yes, H2 comes to cathode and takes 2 electrons. That's why we write 2. Remember, 2 molecules of water come to cathode and take 2 electrons. Just remember it. When we have a very active metal, which is the yellow one, we will get electrons of water. So water comes to cathode, takes 2 electrons from cathode. As a result, what happens? It dissociates. We get a hydrogen, as you see, H2, and hydroxy ions. OH is negative. Why OH? So it will take one electron, we get OH with a negative charge. If we have 2 OHs, we will have 2 minus. If not 1, like it's minus 1. 1 is minus, so there are 2, so they take 2 electrons, not 1 electron. 2 OH groups, each of them takes 1 electron, overall 2. So this is what happens. That's why on cathode, we will get H2 as a product. So this is H2, is a white gas. You will be able next lesson, you will be able to see on the cathode the white gas. Its appearance flying around. So H2 appears in the cathode. Right here, H2. Let's see what next. You see in the picture on the slide as well, we have H2. Let's see what happens on the anode. Look, on the anode, we will get our chloride, this one. This chloride will come to anode. He is negative, yes? So he will give his electron, minus electron. To become neutral, it needs to join the second chloride. we get chlorine to 0. It's gas twice. But in order to become chlorine 2, here we need to have 2 chlorine ions. If one chlorine takes 1 electron, 2 of them will take 2 electrons. Like this. So we're at chlorine 2. Chlorine 2. And this here. Okay. We write products. Okay, what happens now? Look, what happens with our sodium? Because at the beginning we had sodium. Yes? We have sodium. In the products we don't have it. Water, okay, it's a mess as well. Water is, but no, water comes here. This water comes here. Okay, instead of sodium, this water came. This water comes, participates here. We get hydrogen, right? But OH ion. We have OH ion. And this sodium ion that did not participate in the electrolysis. The sodium ion, we said it does not participate. Water participates, we get H2. Okay, what happened with this ion? This ion joins with this OH. And we get sodium OH. And write it here. And also plus H2. Plus H2. Water always remains because. No. Wait. Water participates. Like this. Is it clear now? Yes, please take water. Okay, and now let's talk about metals with medium activity. We control, we check we consider the electrolysis of the salt of an active metal, of a weak metal, in which case they do not contain oxygen. Now let's consider electrolysis of a metal with a medium activity and the salt which does not contain oxygen. It does not contain oxygen. So electrolysis of a, let's take this. You took the photo? Yes. So as a medium activity, we take zinc. Zinc bromide. It was sodium. Look, it's taken zinc bromide here. I will write for reaction. You said when we have a passive metal, nothing will do. Like it just appears on the cathode. If we have an active metal, instead of metal, we will get a hydrogen. Right? We will get hydrogen on the cathode. Where we take the medium activity? In the case of we take medium activity, it's a bit weak, a bit strong. So there will be two things. Both the metal and hydrogen will appear. So on cathode, we will get two processes. This metal itself will appear. Let's write it. The sodium, we just process and sell it will not come, only hydrogen. In our case, zinc will come. So this zinc is a cation. Cation. And so cation will come to cathode. If 2 plus, for becoming 0, it needs 2 more. It will take 2 electrons and become zinc 0. But it's not very passive. It's at the medium activity. It's active enough. That's why the second process also will come. This water will also come to cathode, and electrons of water will also occur. H2O, but we said 2 H2O, yes, as in the previous case. 2 water molecules will come. What will they will give 2 electrons? No, sorry, they will take cathode is negative. They will take 2 electrons, and as we said, we will get hydrogen, yes, and as we said, 2 OH. So this is the reaction from the previous case, like in the case of active metals. So let's see, we have zinc as a product. We have hydrogen gas, it's a white gas, and arrow up. Yes. Let's see. We have OH here. Let's see what happens on anode. Let's go to anode and discuss anode. Bromine anion will go to anode. Okay. So look what happens. Bromine, we have two bromine anions. Will go to anode. Anode is plus, he's minus. He will give how many electrons? 2, yes. He's minus 1. We can give only 1 electron, but there are 2 bromines. If each of them give 1 electron, overall 2 electrons are given. So he gives 2 electrons to anode, and we get again such a halogen, the atomic number, bromine 2, 0. Easily. So we write bromine 2 here. Okay. Well. Then, well, this zinc did not completely participate in the process. Particularly, it participated. Some zinc ions still remain in the solution. These zinc ions that remain in the solution, you see, some of zinc ions came here, but it's not very active, it has a medium activity. That's why not all of them will participate on cathode. Some of them will remain in this form. So this class, this remaining zinc ions, will join with these hydroxy ions, and we will get zinc hydroxide. Electrodes of aqueous solutions of bases, oxygen-containing salts, and acids. So in our case, now we will talk about substances which contain oxygen. You can see what happens if we have oxygen. So here I do copper sulfate. You see it contains oxygen. Why I took copper? Because copper is a passive metal. On the cathode we will not have too long process in order to focus on anode. Because if we have oxygen, on anode we will not have SO4. Instead of having SO4, if there is, you see, if in our anion, we have an oxygen, on the anode there will be such a process. This water will come, water. 2 molecules of water. Anode is positive, yes? So what happens? Water will give electrons to anode. You see, it will lose 4 electrons. And we will get oxygen and H+. This is what we get on the anode. We have oxygen, H+. What happens further? This hydrogen that we get here will join with this, with this SO4 anion. SO4 2 minus. We will get H2SO4. Okay, so in the case if we have oxygen, on the cathode all the processes are the same. That's why I did not write it. But on the anode, it will be a bit different. We will stop here. Okay. Next lesson we will continue. We will do the experiment, and while waiting for the result, for the final, we will talk about continuation.